Okay guys, I don't know what happened to the last video, so I'm redoing example number 2. Remember, you start out with the domain, which gives you the vertical asymptotes. So in this case, x squared minus 1 cannot equal 0. You factor it, x plus 1, x minus 1 cannot equal 0. So x cannot equal negative 1, x cannot equal 1, which means that's where your asymptotes are. So your domain is negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Our vertical asymptotes are at x equals negative 1 and x equals 1. Our horizontal asymptotes, we go back to the original equation. We see that the powers are the same. So you take the ratio of the coefficients. Well, that would be a 1, and that would be a 1. So our horizontal asymptote, y equals 1. So now we can put all of these on our graph, and then we'll go back and do the x and y intercepts. So here we go. We have an asymptote at x equals negative 1, an asymptote at x equals 1, and an asymptote at y equals 1. Now we need to figure out where the curves are going to go. This is the first time we've had an example where there are two vertical asymptotes. So basically now you have three sections to this graph. You've got this section to the left of this vertical asymptote. You've got the section in between the two asymptotes, and you've got the section to the right of this asymptote. Then each of those sections, you're going to try to figure out if the curve is above or below the horizontal asymptote. So you need to figure out if the curve is here or here in area 1, and then here or here, and then here or here. So how do we do that? Well, we can use the x and y intercepts to help us. So how do you find an x-intercept? Well, to find an x-intercept, you set y equal to 0, just like before. And so you have 0 equals x squared over x squared minus 1. And then what do you see? You see that the only way to get 0 would be for the numerator to be 0. So x squared equals 0 means x equals 0. So we have an intercept at 0, 0. Well, you'll notice that that's also the y-intercept, because if you set 0, if you put 0 in for x, you get 0. So that at least helps us to know that the curve in section 2 is below the vertical or below the horizontal asymptote. And the way it works is we know that curves go closer and closer into the asymptotes but never touch. So on this side, closer and closer and closer but never touch. And then on this side, closer and closer and closer and never touch. And now we have to figure out if the curves are on this side, if it's above or below the horizontal asymptote, and the same thing over here. But we don't have any points to guide us, so we have to do a little bit of what we've called before interval testing. So let's pick this value. We'll test x equals 2, and if you fill that in, you get 2 squared over 2 squared minus 1, so 4 over 3, which is bigger than 1, which means it's up here above the horizontal asymptote. So we put this curve right there. And then if we test over here, we can test x equals negative 2. And you can see, since we're squaring the x's, we're going to get the same thing. But negative 2 squared over negative 2 squared minus 1. Again, you're going to get 4 over 3, which tells you that the other curves are also above the horizontal asymptote. And that's it. And we're just estimating the way that these curves look. We don't have to be exact. All we care about is if they're above or below the horizontal asymptote. So let's go ahead and do one more example. At the bottom of the page here, we start, right, by finding our domain, which leads us to our vertical asymptotes. So the denominator cannot equal 0. So that means x cannot equal 0 from the x squared, and x cannot equal 2. So for our domain, it's negative infinity to 0, union 0 to 2, union 2 to infinity. And for our vertical asymptotes, that means x equals 0 is an asymptote, and x equals 2 is an asymptote. For our horizontal asymptotes, we look at the power on the top and the power on the bottom. Well, there is no x up here, so really, n, the power on the top is 0. The power on the bottom is 2. So this one is bigger on the bottom. I'm sorry, this should be d. So if n is less than d, we know we have an asymptote at y equals 0. And some students like to call this bottom heavy. And if you call it, and when something is bottom heavy, you have an asymptote at y equals 0. So let's go ahead and put our asymptotes on. We've got one here. I'm off the screen. We have one here at x equals 0, one here at x equals 2, and then we have one here at y equals 0. Now we need to figure out where our curves are. So we are going to go and try to find the x and y intercept. See what happens. When I fill in 0 for y, I get 2 over x squared times x minus 2. And you can't see that, can you? Let's see. There you go. Try to straighten it out. And the only way to get 0 is if the numerator was 0, but the numerator cannot be 0 here. So this one has no x-intercept. And then if you try the y-intercept, that would be y equals 2 over 0 squared times 0 minus 2, which would be 2 over 0, which is undefined, so there's no y-intercept, which makes complete sense because there's an asymptote on the y-axis and an asymptote on the x-axis, so it shouldn't cross there at all. So now we have to do the testing again to figure out where the other points are. We just have to test every interval. So remember, there's this part. We have to find out if it's above or below. Then this section here, we have to figure out if it's above or below. And then this section here, above or below. So I'm going to start in the middle, and I'm going to test x equals 1. And that means I'm going to fill in to the original over here. We got r of 1 is 2 over 1 squared times 1 minus 2. So that's 2 over negative 1, right, which is negative 2. So we've got the point 1, negative 2, which tells us that the curve is down here. Now we have to test something in these other regions. I'll get a different color pen that I like here. Let's do green. Here I'm going to test 3. Now, we don't always have to test and actually put the number in. If you remember before when we did interval testing, we just decided to look at, am I going to get a positive or am I going to get a negative? So here, if you go back up to the top, the numerator, no matter what you plug in, is always going to be positive because it's a 2. In the denominator, I'm going to square 3, so that's going to be positive. So this part's positive, and then 3 minus 2 is also positive. So this answer is going to be positive, which means it's going to be above the horizontal asymptote. So this one is here. Over here, you're going to test. You can do negative 1, you can do negative 2. We'll test x equals negative 1. Again, we'll just do the quick version of it. And we'll just say, if we look back to the very beginning, sorry, I keep turning it sideways. If you look in the very beginning, you've got the numerator is always 2, so it's positive. When you square negative 1, you get a positive. When you fill a negative 1 in here, you get a negative. So you get a negative overall, which means that our curve is actually down here. You might have been expecting it to be up there based on where the other one was, but it's down here. And that's it. So we've got one more example coming up in a minute, and then you're going to try some on your own. But before we do that, I need to fix a mistake, and I'm not re-recording. So down here, I said that d was 2, but since this is squared and this is 1, d is actually 3. It doesn't matter because it's still bottom heavy. It doesn't change anything, but I did want to go ahead and fix my mistake. So that's it. Be back soon. And we've got one last example here. Again, you start with the domain, which means you look at the denominator. X squared plus x minus 2 cannot equal 0. and we factor x plus 2, x minus 1 cannot equal 0, so x cannot equal negative 2, and x cannot equal 1. The cannot equal is just for the domain. When we do the vertical asymptote, we write x equals negative 2 because the asymptote is negative 2, and then meaning that our x values themselves cannot be negative 2. So anyway, the domain, we have negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And then our vertical asymptotes, x equals negative 2 and x equals 1. And then our horizontal asymptotes, we go back up and we look at the highest powers here, right? In this case, n equals 1, that's the power in the numerator. D equals 2, power in the denominator. And it's bottom heavy. And we know that when it is bottom heavy, we have the asymptote y equals 0. So let's get our asymptotes on here. We've got negative 2. We've got x equals 1. And we've got y equals 0. Now we have to try to figure out where the curves are. And this example is a very unique example in that when we try to find our x and y intercepts, you'll see that when you plug 0 in for for y, and then you have 2x over x squared plus x minus 2. The only way to get 0 is if the numerator is 0, which would mean x equals 0. And so that means our x-intercept is at 0, 0. Well, if 0, 0 is the x-intercept, that's also the y-intercept, but notice it's right on the asymptote. And that happens on rare occasion where it will cross the asymptote. So let's go ahead and see what's going on this one. We are actually going to have to test on either side of that to see where our curve is. But let's go ahead and test on the right-hand side here. Let's test x. Oh, let me move this over. Let's test x equals 2. And so if I plug in 2, we just want to know basically if it's positive or negative, where the curve's going to be on this side, right? So if I plug in 2, I'm going to have a positive on the top. And then I'm going to look at the factors here. I'm going to look at it factored because it's easier. So if I fill in 2 here, I end up with a positive and a positive. So the whole thing's positive. So that means the curve is up here. And then let's go ahead and do this side and test, because that's going to be the second easiest thing to do. I'm going to test x equals negative 3. If I do that, I get a negative in the numerator. And then in the denominator, I'm looking at the factors here. I would get a negative times a negative. So overall, I'm going to get a negative. So that means my curve is down here, below the asymptote. Now, this guy in the middle is a little bit tricky, like I said, because it's going to actually cross the asymptote. It does happen sometimes. So now we have to see what's happening. We're going to test, I'm going to go down here, we're going to test x equals negative 1. So if we look at our equation, we're going to have, if we take 2 times negative 1 in the numerator, then we have a negative at the top, and then negative, over to this one, negative 1 plus 2 is positive, and then negative 1 minus 1 is negative, so this is going to be positive. So that means this side of where it crosses, it's positive. So that means it's coming up like this. But we don't know if that means that this also comes up, or it could possibly come down like this. Because it crosses, chances are it comes back down. Notice that before, the dots didn't cross anything. So if it was here, if it had been above it, you just make your parabola and be done with it. But this time it's on the asymptote, so we have to test between here and here. So we're going to test x equals 1/2. The nice thing about it is, remember, we don't have to fill it in. All we have to do is say, if I fill in 1/2 in the numerator, I get a positive number. If I fill in 1/2 in this factor, I get a positive. If I fill in 1/2 here, I get a negative. So this one's going to be negative, so I know that it comes below right there. And that is all of your examples.